Welcome back for the second one. We just learned about what a radian is, and now that we have that knowledge, armed with that knowledge, we have two goals. Two goals for this video. Goal number one is to be able to find what's called coterminal angles. Coterminal angles, we'll get into that in a second, okay? Goal number two is to be able just to convert back and forth between them. If I give you a number of degrees, how many radians is that? If I give you the number of radians, how many degrees is that? Think about it as like translation. Hola means hello in Spanish, but they mean the same thing. They just got to translate one to the other. It's the same thing with degrees and radians. So let's get after it. Let's get those two goals going, okay? First thing I want to talk about. This is 4-1. If you want to put this in your notes, be my guest. All quizzes are open notes. To be able to measure an angle, we first have to draw an angle. And an angle is made from two rays, two sides. We talked about that before, okay? So for us, we have an initial side where we start from, and we have what's called the terminal side where we end. Initial, terminal, right? So we start here, initial side. We rotate that to where it ends. It's the terminal side. That angle, how far we rotated that, is how many degrees or how many radians, okay? I drew this just kind of willy-nilly. How we will always draw this, it's called standard position. We're always going to put the initial ray, the initial side, on the positive x-axis, and then we're going to rotate counterclockwise. It's pretty weird. We always want to do things clockwise, but in trigonometry, we are not going to do clockwise. We are doing counterclockwise. So I have my initial side. I'm rotating that thing to my terminal side, and that central angle we just made coming from the center, that's the angle that we're talking about, how many radians, how many degrees, so on and so forth. So a second ago, I told you one of my goals here was coterminal. We want to be able to find coterminal angles. Well, now the word terminal. Now we see what that means. They're going to have the same initial side and the same terminal side, but they're going to be two different angles. We'll see what that looks like, okay? Here's a couple of things I just want to talk about. We would not normally talk about angles being negative, but we can now. If we ever rotate in a clockwise direction, we would just call that a negative angle. Negative 30 degrees means 30 degrees in that direction. Negative pi over 6, that's the same as negative 30 degrees. Okay, we'll use theta for our angles the most, T-H-E-T-A, theta, or alpha or beta. They're just Greek letters. We can use any of them, but theta is the one we like to use the most. We go counterclockwise. Okay, here it is. Here's our definition for coterminal. Two angles are considered coterminal if they have the exact same initial side and terminal side, but they're different angles. Okay, so an easy one to talk about here. I drew one. Going from my initial side to my terminal side in the counterclockwise direction, the positive direction, that would be alpha. But then I could also rotate it the opposite direction and go around and get the exact same two legs here, the same two rays for this angle, beta. Those two angles would be called coterminal. They have the same starting point and the same ending point, but they're two different values. Okay, coterminal angles. Okay. This would have been the point in the notes when I did a little bit of neighbor talk. Turn and talk with your neighbor. And I want you to find 3 coterminal angles for 25 degrees. And I want at least one of them to be in the negative direction. It needs to be a negative angle. So hit pause if you need to. Draw yourself a picture if you need to, but take some time and find 3 coterminal angles for 25 degrees. Okay, hopefully you're back. I talked about drawing a picture, and that's helpful. So I'm going to draw, we always talked about an XY axis. We're always going to start from the positive, and then we want to go 25 degrees up. So maybe that's somewhere around here. Initial side, terminal side, 25 degrees. So now I want another one that starts and ends at those two, but isn't 25 degrees. Sorry, 25 is hard to see. Okay. One way we can think about it is we could say, well, I could just go all the way around the circle to begin with, 360, and then 25 more. Okay, so 360 and 25 more, that's just adding. That would be 385 is one. 385 degrees is coterminal with 25 degrees. They have the exact same starting point and ending point, but they're two different angles. I'm going to switch to a pen here because that pencil isn't doing what I need it to. Okay, how about another one? Well, we could just go around the circle again. I could go around twice. 360, 720, and then 25 more. Sorry, let me do it again. 360, 720, then 25 more. Okay, so 720, 25 more. We could say 745. Are we picking up what I'm laying down? How could we do another one? What are we doing each time? How about the negative one? So in this case, I could go 360 in the opposite direction. So that would be a negative 360, and then add 25. Negative 360, but then I'm going to add 25. Well, commutative property of addition here, I know you haven't heard that in a while. We could just flip those around. That's just subtracting 360. 25 minus 360. Negative 335. Yes, hopefully. Okay. So we need a trick. There's 3. 1, 2, 3. They're all coterminal. They all start and end at the exact same spot, but they're 3 different angles. Well, what's the trick for it? Oh, and if you saw that, pretend like you didn't see that. What's the trick? Okay, well, each time on these, I'm just adding 360 to get to this one. Then add 360 to get to this one. Then I could add 360 to get to this one. Or going in the opposite direction. Subtract 360. Subtract another 360. The trick is to add or subtract 360 degrees to get your coterminal angles. Easy. Okay. Try this one now. The next one is going to be find 2 coterminal angles for pi over 5 radians. So we're not talking degrees anymore, but that's okay. We know the translation. I want to be able to find 2 coterminal angles for pi over 5 radians. Okay? Well, if the trick was to add or subtract 360 when it's in degrees, the trick here is going to be to add or subtract 2 pi, because we know 2 pi is the same as 360. That was our big aha from our first video. So pi over 5. I could add 2 pi to get to, it's like going around the circle again, in the positive direction, or I could subtract 2 pi to go around the negative direction. Okay, well, common denominator stuff, times by 5, times by 5, that's 1 pi over 5, plus 10 pi over 5, that's 11 pi over 5. There's 1, that's coterminal. Same idea here, we'll multiplying the top and bottom by 5 to get common denominators. 1 pi over 5 minus 10 pi over 5, 1 minus 10, negative 9 pi over 5. There are 2 coterminal angles. Remember, our goal was to come up with coterminal angles in degrees or radians. Basically, anything you do in degrees, you can do in radians. It's just a different language. We can still do all that same stuff. Eventually, I'll have you find the supplement, the complement. We used to do that in degrees in geometry. We can do it in trigonometry just with radians. Okay. One last little thing I want you to do. This table is uber important. You need to know this. Okay, we need to be able to convert back and forth between these. Now, is there going to be a test on this? I'm not saying that. Is there not going to be? I'm also not saying that. Double negative there. But you need to know these. 360 degrees, I got that one. Cut that in half. Or 360 degrees, that's 2 pi radians. We just did that. If I cut that in half, how many would that be? If I cut that in half, how many would that be? If I cut that in half, how many would that be? We can keep playing that game. We did 30 degrees. Well, I could double that to get this one. Fill out that table. Get good at that. Practice that. We're going to use these a bunch. Okay, that was goal number 1. Goal number 2. Changing from degrees to radians. So I'm just going to throw a problem at you. See if you can do it. I want you to change 4 pi over 7 radians. I know it's radians because it has pi involved. 4 pi over 7 radians. Change 2 degrees. Change 2 degrees. If you need to hit pause, go ahead and hit pause for a second. Give her a whirl, see what you can come up with. Okay, we're back. 4 pi over 7 radians. We have those conversion factors. We have these little stepping stones, if I've described that to you yet. But right now, these are in radians. So I don't want it to be in radians. So I know in my conversion factor, whatever I do, I need radians to be on bottom. Okay, well, the conversion factor I know is that 180 degrees is pi radians. So you can think of this as radians. I don't like writing it because it's not really there, but to help you guys, radians, pi radians. The radians cancel. Good, I'm left in degrees. That's what I wanted. Change to degrees. Now it's just some math. Well, pi over pi, those cancel. I can do 4 times 180. Go across. Divide by 7. That gives me 102.9, about 102.9 degrees. Check. There's our little conversion factor. If you ever want to change from radians to degrees, from rad to degrees, we're going to multiply by 180 over pi. Okay? So then backwards, if you ever want to go from degrees to radians, you just need to multiply by pi over 180. Those are our little conversion factors. We can multiply those together because really this is like a fancy form of 1. 180 degrees, pi radians, they're the same thing. If you're dividing something by itself, that's 1. We're just multiplying by 1. A fancy form of 1 that helps us out. Okay, here it is all neatly done. There's your guys' next stamp. Or it might be a piece of the stamp. More to follow. But for now, I want you guys to try these on your own. Page 367, 1 through 17, all odds. It's practicing the two things we got after just now. Coterminal angles. And then converting degrees to radians, radians to degrees. That's it. We're moving on. You guys are kicking butt. Ask me any questions that you need. Send an email to me, but we're moving ahead.